Hello and welcome back to my YouTube channel. In this video, I'm going to discuss the notion of set. What are sets or what is a set? Well, a set is a collection of distinct objects, meaning that each object in the set or in a set is unique and does not repeat itself. And so a set can be a collection of anything. It could be a collection of cars, distinct cars, collection of animals, collection of numbers, and so many other collections. And so let's say we have a set X. In this case, we are using numbers. Let's say X has elements 3, 4, 5, 12, and 13. Let's have another set Y. This Y could be anything. It could be A, it could be B, it could be C, or it could be anything. So we are using Y. Let's say that Y has, or the set Y has elements 13, 14, 15, 6, and 3. Note, when we write the elements of the set, we put curly brackets at both ends of the element, and then we use commas to separate each element of the set. Which two operations can we perform on this set? The first operation we are looking at is the union of the set, and we use the symbol U like this to represent the union of a set. So we write X union Y. Just like so many other people, you can replace this union with all, meaning that X union Y are elements that are in set X or set Y. And so 3 is in set X, so you write 3. 4 is there, so we write 4. 5 is in set X, we write 5. 12, we have 12. 13, we have 13. We have 13 here. We move to set Y, there is also a 13 here. But from the definition of our set, the elements of the set should be distinct. So we can't repeat the 13 we wrote in the union. Because we have already have 13 here, we are not going to repeat or write the 13 in set Y. We move to the next element, which is 14. And then 15. And then the next element is 6. The last element is 3, but we have already written 3. So we just close the set with a curly bracket. And so what do we have here? X union Y are just elements in X or Y. We put them together and then we write them as another set. Alright, the next operation we'll perform on this set is called the intersection of the set. And we use this symbol to represent the intersection of set. X intersection Y, they are just elements that are in both sets. So if you see an element in the set X and you see the same element in the set Y, then we write them in their intersection. And just like many others, the intersection could be replaced with the word and. So X and Y, meaning that the elements are in both sets. 3 is in both sets. 3 is here, 3 is there. So we write 3. 4 is in X but not in Y. So we do not write 4. 5, 2, and 12, 2. The same. When we look at 13, 13 are in both sets. So we write 13. And then we close the bracket because there are no more elements that are in both sets. Now, looking at this, X intersection Y have elements 3 and 13. Meaning 3 and 13 are in both X and Y. Let's take a look at another example. Here we look at a collection of alphabets. So let's say set A has elements A, I, O, and U. And let's have another set B. Let's say set B has elements A, B, C, and D. Sorry. Now, A intersection B are elements in both A and B. As you can see, A is here and A is in B too. So we write A. E is here, E is not in set B. I is here, I is not in set B. Same applies to O and U. So in this case, A intersection B is just the element A. A union B are elements that are in A or B. We have A here, we have E, we have I, O, U. We have A here, but A has already been written because the elements are distinct. We do not repeat them. The next element is B, and then C, and then D. So you could pause the video and then reflect on this a little. The next thing we are going to do is to represent this thing on a Venn diagram. All that we have written here, we are representing it on a Venn diagram. What is a Venn diagram? The Venn diagram is just representing these things in a form of a diagram or in a diagram form. It's a graphical representation of sets. Sorry. So the first thing is we are going to draw a bigger set like this, and then the next thing is that we are going to draw the smaller set, which is A, the set A, and then the set B. Now we are going to use a circle. You could use any figure. So in my case, I'm using a circle to represent the set A, and then a circle to represent the set B. Now, where this circles meet is called the intersection, meaning they are the elements that are in both A and B. And here, our intersection was A, so we put A here. All the elements of A are supposed to be in this circle. But since A is already in the intersection, so we write the rest of the elements of A, E, I, O, U. E, I, O, U. We write it in this part, E, I, O, U. Do you get it? Same thing applies to the set B. A is already written in the intersection, and so we write the remaining elements, B, C, D, in the other parts of the circle. And that's it for now. Thanks for watching. Okay, I put so much work into making this video, so the best you could do for me is to like this video, subscribe if you haven't, and